Hello everyone, welcome to another video. Well, as you saw in the previous clip, the Avensis has been having some starting issues and decided to get it resolved today. In case you're new to the channel, you're welcome. Please subscribe so that you get notified whenever I upload a new video. Lots of informative content on this channel. And to my returning subscribers, thanks for sticking around. I really appreciate you all. So, let's dive right into the starter issue. I decided to take out the starter to investigate further. So with the airbox and the intake hose out of the way, had enough room to get at the starter. 2 bolts holding the starter to the bell housing. One accessible from down here and the other on the other side. Then the electrical connection. Here it is. The main positive cable coming from the battery, held on with a 12mm nut right here. Popping this cover off, reveal the nut, and then the solenoid connection right here. So let's head over to my workspace where I'll explain further. So here we have my workspace. So here's the starter model. This is actually from another car because I already took the Avensis starter apart. So I'll briefly explain how starters work. So, like I earlier showed, we had 2 connections going to the starter. One directly from the positive terminal of the battery, and then the other connecting the solenoid. So once you turn the key on your car, the solenoid gets energized, and then with the whole starter motor grounded by the engine to the body of the vehicle, once the ignition gets turned on, the solenoid gets activated. Once it gets activated, it serves 2 purposes. It bridges the contacts between the positive terminal coming directly from the battery and this terminal right here going into the DC motor portion of the electric motor starter. So that's one function. It bridges these 2 terminals together so that it powers the DC motor. And then in addition to that, the solenoid actually moves the pinion gear right here, the part that engages with the flywheel on the vehicle. It moves it forward so that the pinion gear can engage and spin the flywheel on the vehicle and thereby turn the engine so that it can start up. So that's what the solenoid does. So obviously with the contacts bridged, the DC motor spins, and with the pinion gear pushed out at the same time, we get our vehicle to run that way. So that's how the starter motor on vehicles, or most vehicles, work. Obviously hybrids and electric vehicles don't have this setup in them. So with the Avensis starter motor out of the vehicle, I tested on the bench or with the starter motor outside the vehicle, and it checked out fine. But the symptom I was getting, intermittent disengagement of the starter motor to the engine, implying that once in a while I would actually hear the starter motor run, but the engine won't be spinning, and therefore the car won't start. So upon further investigation, I concluded that the DC motor end of my starter motor was fine, because obviously I could hear something spinning, something like a machine. It was just that the engine wasn't turning to start the car. So upon investigation, initially I felt my solenoid portion was faulty and wasn't causing the pinion gears to engage properly with the pinion gear here to engage properly with the flywheel. But after digging further, I realized that there was a system on the pinion gear, similar to how bicycles operate. So let me show you what I mean using an actual bicycle. So a lot of us are familiar with bicycles. Here's my bicycle right here. We have the chain, the crank, and in this case we have a free wheel. So what the free wheel does is it helps to transmit power from your pedaling motion through the chain. It transmits power to the rear wheel using your chain, and then it gets onto this right here, a set of gears. The interesting thing about this is as we pedal forward, the bicycle wants to move forward, but going down a slope or just going down a slope where we don't need to pedal at all, we can hold the pedal still without the pedal constantly rotating fast as the rear wheel is spinning. What enables that to happen? This right here. It enables power to be transmitted going forward, but we can spin this backwards without any motion of the rear wheel. So what enables that is this free wheel. It enables movement in one direction and then free wheels, as the name implies, in the other direction. So I'll show you an actual free wheel and explain further. Here's a free wheel taken off my bicycle. So as you can see, if I held onto the back of the free wheel here and tried to spin it, it will actually spin in one direction, this way. I'm still holding onto the back here to actually spin, but if I try to spin it in the other direction, my right hand would also want to spin, meaning that the free wheel locks in one direction and then spins freely in the other. Similarly, on car starters, on the pinion gear, we have a similar mechanism. So if I held onto this, I could spin it clockwise this way, but if I try to spin it in the other direction, the whole assembly tries to move. So the importance of that on a starter motor, here I have the starter motor here, a complete assembly. So once the pinion gear gets pushed out by the electrical solenoid and engages with the vehicle flywheel to start the vehicle, at some point, once the engine is started, because of the size of the flywheel, there'll be a tendency for the flywheel to turn the electrical motor in here, the DC motor in here, and if that happens, that would definitely damage the electrical motor. So we have this pinion gear, or a free wheel, at times is also called an overrunning clutch, whereby it prevents power from being transmitted back into the DC motor, the armature or rotor portion of the DC motor, which can damage it by causing power to be effectively not sent back into the DC motor, but DC motor could send power to turn the flywheel. So that's the purpose of this right here. It's called the overrunning clutch or free wheel clutch on car vehicle starters. So with the symptom I was getting and with all my investigation, I realized that this wasn't actually locking completely in one direction, in the direction which will enable the vehicle to start, and that was why I could hear the starter motor turning, but the engine wasn't turning. So I'll be replacing this portion right here with a used one. So follow me along. So before we put everything back together, here's showing the various components of the starter. We have a planetary gear set on there, the shaft where I'll be fixing the pinion gear. So here we have the DC motor part showing the armature and the magnets on the stator. So assembly begins here. So I'm applying some grease to the shaft and the bevel gear on the where the pinion gear is going to fit onto, so that things move a little smoothly or very smoothly. So I just slid on the pinion gear, attaching the arm that is going to be pushing the pinion gear, placing it on the DC motor portion here. Decided to fix the circlip and the shell into the groove on the shaft. That was the extremely difficult portion. I must confess, it took me about 20 minutes because I really tried hard not to injure myself. I'm glad I was successful at doing that. So basically, the difficult part is getting the circlip onto the groove on the shaft and then putting the shell around it to lock it in place, using a plier here to reduce the diameter. So here's showing a close-up of where the circlip and the shell is to fit onto. I ended up using a plier to reduce the diameter of the circlip and then slid on the shell and then put the circlip into the groove, and then eventually using a 13mm box end wrench tapped the shell to lock it in place. So I have it all installed right here. Here's another view of that, and then assembly continued. So reinserting the upper portion here, lined everything back up. Pretty straightforward. Not the job is not as difficult as it seems. Not so many components. Quite easy to assemble. Just follow the steps. Initially, I put on the casing there, bolted everything back up, and then realized that the solenoid plunger was proving difficult to put on. So after tightening everything, just make sure they're snug. You don't want to go too tight because you don't want to strip any threads on there. Here I'm using a 1/4-inch ratchet and holding onto the base, not the tip, so that I don't apply too much torque. Tightened everything back up. So checking everything right here, looks good. It's much easier fixing the solenoid plunger before bolting the case on, like I'm doing now, like I just did. I just hung this on right here before bolting this back to this. So after tightening down the DC motor back to the casing, applying some lube to the solenoid plunger here, and then there's a spring. Don't forget that. Reattach the solenoid itself back to the assembly, line everything up. Because of the springy nature, you need to hold it in place. Always start off your threads by hand. Don't force anything. You don't want anything getting damaged at this stage. So I'm fixing the Phillips head screws, snugging them down. And then here's what we have. Using my 1/4-inch ratchet and the Phillips head bits, tighten it down. Don't go too crazy. Make sure it doesn't slip so that you don't get the Phillips head screws damaged. Just snug them down. Don't go too tight. So that's it. I think we're all good. Make sure the bolts for the electrical part are also tight. Now I'm tightening up the nut from the motor to the solenoid assembly. Don't go too tight on that either. You'd observe I'm holding the 3/8-inch ratchet at the base so that my torque will get limited. You don't want to go crazy here. You don't want to damage the solenoid here. So with the starter fully assembled and all the bolts and nuts tightened, that's 2 bolts, this and this, then this nut right here, and then these 3 Phillips head screws. Ensure that your overrunning clutch doesn't swing out by itself, because if it does that, it means that it's going to be catching on the flywheel. So in this case, it's pushed back in by the solenoid. It means you did everything right. So here it is. So right now I'm going to reinstall this on the vehicle. See how it goes. So right now everything has been put back together. Starter was installed successfully. Ensure you don't over tighten the nut on top of the solenoid so that solenoid doesn't break. Then the starter bolts, you can look up your torque specs for your vehicle. So right now, the moment of truth. Let's see if the car starts up. So that's it, folks. Started pretty good. I'm going to shut it off and start it again. Let's see how it goes. So that is the cause of the intermittent issue I was having with the starter. That's the pinion gear freewheel or overrunning clutch, as you may want to call it. Most people would rather replace the whole starter because it takes some time to disassemble the starter and then put it back together using the replacement part. In case you decide to go down the route of replacing the pinion gear and trying to identify it, we have some part numbers written on here. On the starter itself, it's a Bosch starter made for Toyota. So looking up these part numbers and cross-referencing them against either a Bosch or Toyota would bring it up for you. If I were to buy a brand new pinion gear, it would have cost me about $20, but I decided to go with a used part, and so far it seems to work fine. I can't really tell how long it's going to last, but I guess since I can get it done myself, it doesn't really matter. So, hope you found the video useful, informative. Don't forget to leave me a like. Also, remember to share the video with your friends and loved ones and whoever may benefit from it. Subscribe in case you haven't done so already. Thank you all for watching. Do have a great day. Bye.